All right, guys, so the next thing we're going to look at are operations of functions. I don't know if there's much you need to write down on this page. I think just seeing it is enough, but there's operations on functions, 4 operations: addition, subtraction, multiplication, and division. With addition, with all of these actually, what I want you guys to see is that to add 2 functions is the same as adding the individual functions separately, okay? But what's important to remember here is what you're really doing is you are creating a new function. Remember, when we do this function notation f of x, this f out front is just the name of the function, right? So right here, f plus g, that's just the name of the function. Now, to make that function, you're adding f and you're adding g, the 2 functions, but this here on the left-hand side is a complete new function, right? I'll show you what I mean by that shortly, okay? So nothing here really too complicated. Subtracting is subtracting the 2, multiplying is multiplying the 2. What's going to be new for you guys this year is that when we do these, we must consider 3 pieces of the domain here. The original functions, f and g, and the domain of the new function. Sometimes you'll have some new restrictions based on the operation and what it creates. All right, let me show you what I mean. So first, pretty straightforward. Let's add these 2. The 2 functions we're using are, there we go, are this f and this g. And what we want to do first is just add them together. All right, so this function f plus g of x is going to be f, which I'll do in blue, which is 2x squared plus 3, plus g, 4x cubed plus 1. All right, so what we're going to do here is we're going to clean this up a little bit, but when we talk about the domain, right, we have to think about all 3, the f, the g, and the new function. So when I'm looking at f here, I'm looking for those 2 red flags. I'm looking for denominator or a square root. I don't see either of them, so I'm good. Over here, I'm looking for a denominator or a square root. I don't see any, so that means the domain's all real numbers. In my new function, I'm looking for a denominator or a square root. Again, neither of them. So because I don't see any of my red flags, the domain here is going to be all real numbers. Now that you can use all real numbers, you can also use this symbol here, this funky R that stands for all real numbers as well. And to complete this new function, f plus g of x, all I have to do is combine my like terms. So 2x squared, actually, sorry, I'm going to put the 4x cubed out front. I'm going to go in standard form, which is the exponents in decreasing order, 4x squared, and then plus 4. All right. That is my composite function, right? Or I'm sorry, not my composite function. That is operations on my function. All right. Next, let's subtract them. Okay, the subtracting of them, again, not too tricky. The only thing you have to watch out for here is that minus sign. So first function is 2x squared plus 3. When I subtract that, I want to subtract the whole thing, 4x cubed plus 1. So parentheses, just like we did in that difference quotient problem. Again, pausing to check my domain. F doesn't have any restrictions. G doesn't have restrictions. My new function, f minus g, doesn't have any restrictions, so my domain is all real numbers. Now to clean this up, I'm going to distribute the negative in, minus 4x cubed plus 1, and then I'm just going to combine like terms. So my new function, f minus g, again, f minus g is just the name, is negative 4x cubed plus 2x squared plus 4. Nope, sorry, hold on, go back. I made a mistake. So this is a good example to see, checking your work. I forgot to distribute the negative 1 into that. So I'm going to make that a minus 1, which makes this a plus 2. All right, see, we all make mistakes. The most important thing is to catch them, right? All right, so there is my new function made of subtraction. Let's go down here and multiply them now. So for multiplication, I'm going to multiply 2x squared plus 3 times 4x cubed plus 1. And this is just a FOIL, kind of like what we did before. But before we do that, we're going to check the domains. F has no restriction. G has no restriction. My new function, no restriction. So again, all real numbers. Now to clean this up, I'm going to FOIL it out. So first is 8x to the 5th. Right? Outer is plus 2x squared. Inner is plus 12x cubed. And last is plus 3. So if I clean that up, 8x to the 5th plus 12x cubed plus 2x squared plus 3. And that is f times g of x. All right. Last but not least, let's divide them. So we want to divide f and g. So this is 2x squared plus 3 divided by g, which is 4x cubed plus 1. All right. Now the 3 spots I got to check. Check this original f, no restriction. Check this original g, no restrictions. But in my new operation, in my new function created by dividing f divided by g, I have a restriction. I have 4x cubed plus 1 in the denominator. Just like before, 4x cubed plus 1 cannot equal 0. And I have to solve it. So 4x cubed equals negative 1. I'm going to just move this. Kind of looks weird on the line there. So we'll move it there. All right. So can't equal 0. So I'm going to divide both sides by 4. Now here, where you saw with, if it was x squared and I square rooted both sides, you're not allowed to have negatives under the radical. But if you remember with cubes, it is okay to have a negative under the cubed root. So my final answer here is going to be x, and this, remember, should be not equal, cannot equal, right? Make that cubed root a little nicer. So cannot equal the cubed root of negative 1/4. Now, I don't know what that is off the top of my head. If you want to go type it in the calculator and give me a decimal, that's okay too. But the domain here is simply x cannot be. Now we'll do it just both ways. Set notation, values of x such that x cannot be the cubed root of negative 1/4. Or we can do it in interval notation, which is negative infinity to the cubed root of negative 1/4 union cubed root of negative 1/4 comma infinity. So remember, 2 ways to describe the domain, set or interval notation. Let me show you over here. If it is all real numbers, interval notation, that's just negative infinity to infinity. Okay, so 2 ways to show it there. And then back up here, my f divided by g of x, that's as much as I can clean up. There's no simplifying. I would look to factor the top and bottom, but if I can't do anything, that's as far as I can go. All right. Those are the operations. Now, one quick point I want to make here, all right? If I ask you to find f plus g of 3, okay, there's 2 ways you can do this. There's 2 options. Option 1, you can take f of 3 and add it to g of 3. And you do it in 2 steps, and you're done, okay? Option 2 is to take what we did up here, okay? So remember up here, we found f plus g. Copy that, move it down here. We already know what that is. So if I put that down here, right? Now, remember, f plus g is just the name of that function. So if I wanted f plus g of 3, I don't have to do the 2 steps I did over here. I could just take that 3 and plug it in to that new function I found here, plus 2, 3 squared plus 4. So this is the advantage to doing these operations. I can do a 2-step procedure and make it a 1-step procedure now by just plugging that 3 into that new function called f plus g of 3. Now we're not going to clean it up from there, so then evaluate like we did before. But I just want to show you the 2 options when you see something like f plus 3 of g. Oh, sorry. All right, so that's it.